Hello everyone, my name is Ketuktula Zulu. I'm the man behind the content. The purpose of this channel is to make everyone that is in high school from grade 10, grade 11 and grade 12 to grow under mathematics. That is my purpose, to make everyone pass this subject. So now I would like to thank everyone who's been supporting me on this channel. Guys, thank you so much. I really appreciate your support. And another thing, please, if you are watching this video, you haven't subscribed, please subscribe, like, comment, tell me what I need to improve on, tell me what you want on this content. I really want to engage with you. Thank you so much, God, for supporting. Cheers.
Okay guys, now continue with our video by deriving. We'll be doing this question where it's question 9, where we'll be deriving using first principle, where it's saying f of x is equal to x squared plus 3x. We need to derive this using first principle. How to derive this using first principle? Our general equation of first principle is f prime into lim, where h approaches 0, into f into x plus h minus into x of x all over what? All over h. So now we can find our f into x plus h separately by just finding f into x plus h is equal to, we'll just substitute x plus h squared plus 3 into x plus h, where this is just x squared plus 2xh plus h squared, and then times this just gonna be 3x, and then this is just gonna be 3h. Do we have any like terms here? I don't think so. I don't see any, so we can just say f at x minus f at x. We can also find this one by just saying f at x. There are many ways of doing this thing. It depends which one that works for you. Some of the people, they prefer this one because they're simplifying it before going to the fraction part. And minus, which is this minus into fx. What is f at x? Is just x squared plus 3x. So x squared plus 2xh plus h squared plus 3x plus 3h. This times this just negative x squared. This times this just negative 3x. And from here, this cancels this like terms. This cancels this like terms. We are left with 2xh plus h squared plus 3h. Then from here we are done. There's nothing we can simplify more. Going to our equation where we have f of prime of x is equal to lim into h approaches 0, where our f, where this part we've already simplified, which is this one, just gonna substitute it by x, 2 into x h, and then plus h squared, then plus 3h, and then all over h. And then from here we can take a common factor, which is h, and then which is just h into 2x plus h, and then plus 3 all over h. Then this cancels this. We are left with lim into h approaches to 0, which is just going to be 2x plus h. Then from here we can substitute what? our 0 here. By substituting the 0 into this one, now there is no plus 3, sorry guys, plus this 3. Then by substituting our 0 here, now there is no need of putting the limit, so we just say 2, we just say 2 then 2x, then plus 0, and then this plus 3. Then our answer is just 2x plus 3, which is our derivative using what? First principle. Guys, we will continue with our questions. Now we will do 9.2.1 when it's saying we derive y is equal to 3x squared times cubed root of 8 into x exponent 4. We're deriving this in respect of dy dx. So we need to derive this equation that they gave us here. First, we can derive it like this. We have a cube root, so we need to simplify that cube root. How do we simplify that cube root? We're gonna say y is equal to 3 into squared, and then times cube root, just gonna be 8 x into 4, all this thing into 1 over with 3, and then y into 3x squared. We can change 8, making it into a prime factor of 2 into 3, prime factor of 8, then x into 4, all this thing into power 1 over 3. We are still simplifying, that's why we keep on going it down, y like this, and then x squared, and then now this times here, and 2, then this exponent here is going to times this, which is just going to be 3 times 1 over 3, and x into 4 times 1 over 3, and y is equal to 3x squared. Then 3 times 1 over 3 is just 1, so just gonna have 2, and then x times 1 over 3 is just 4 over 3. Then from here, numbers and numbers times each other. 3 times 2 is just 6, and x, and then x, same base. If you have same base, you just add the exponent. That's a rules of exponent. So it's just going to be 2 plus 4 over 3, and y is equal to 6. And what is 2 plus 4 over 3? It's just 10 over 3. So we have x into 10 over 3. Then from here we have simplified everything. Now it's time to derive. So deriving y into the x, we are saying 6 times this exponent is going to times the coefficient 10 over 3, then x into 10 over 3 minus 1, then you just gonna have 6 times 10 over 3, which is just 20, and then 10 over 3 minus 1, which is just x into 7 over 3, and we are done. This is how we deriving this one. Thank you so much, guys. Now the second one, where they saying deriving this one, now where we have x cubed minus 5x squared plus 4x all over x minus 4. We need to derive this one now. But deriving this one, we can derive it since we're having what? A fraction like this, where you have over something and you have a variable here. The first thing that you need to do there is to factorize what we have on the numerator. How do you factorize it? We have x, we have x. First thing, we have a common factor of x, And then if we're taking a common factor of x in x cubed, we're left with x squared minus 5. Or if we're taking x in x squared, we're going to left with 1x, then plus 4. If we're taking x into x, we're just going to left with what? With 4 all over, or x minus 4. Then here, now we can factorize that part, which is a trinomial part. I hope you know how to factorize. If you don't know, please go and learn how to factorize. If you want a video and teaching you how to factorize, comment down below so that I can make a video where you learn how to factorize, finding the factors. And then now from here we have 4 and 5. We need to find factors where we multiply two numbers that are gonna give us 5, are gonna give us 4, but when we're adding them, they're gonna give us negative 5. So we're gonna have 4 and 1. This times this give us 4, but now we need the sign where it's gonna give us positive 4 when we times these two, but when we add them, they're gonna give us negative 5, which is negative and negative, because negative times negative gives you positive, and also negative 4 minus negative 1 is negative 5. So that one seems correct. And then x minus 4, and this cancels this. What we are left with, we are left with this x here into x minus 1. Still f at x, still f at x, still f at x. Then from here you can just times this, and this just gonna be x squared, and this times this just gonna be minus x. And then from here we can deriving f prime of x is just 2x, then minus 1. Then we're done with factorizing this. This times this is 2 minus 1 is 1. 1 times 1 it's 1. 1 minus 1 it's 0. Anything raised by 0 it's 1. That's why we have this one. Thank you so much.